it's such a short chapter, it's just a test. But like I'll have, obviously it'll be open note, but then I'll also have like all the little rules embedded in the test or something, like a little, like what's it called? Like equation sheet or formula sheet or something. Okay. So, oh, let me share my screen. I almost forgot. People at home, can you see my screen now? Excellent. Okay. All right, so topic 4.1, today we're going to talk translations and reflections. This first section is a little vocab heavy because there's just some terminology we have to know in order to be able to do these properly. And then the next couple sections is really just like applying different rules. So 4.1, translations and reflections. The first vocab word we need to know for this is called a vector. A vector is a quantity, like a number, that has both size and direction. Okay, so it is a quantity that has both size and direction. It's like a vector is like what you move a shape around with. You move it with a vector. It's represented in a coordinate plane by an arrow drawn from one point to another. So if you take a look at this little picture down here, see these lines, all these little arrows, right? These are vectors. And what this vector technically did is it took a point P, and it moved it to point Q according to the arrows, right? The green arrow is just the total, like where it moved to, and then these little black arrows is showing you technically that point P moved right 5 and then up 3. So those are like your vectors that it moved along. When we move things in a coordinate plane, we're going to have an initial point and a terminal point, which should hopefully be reasonably self-explanatory there. But the initial point is literally the starting point of the vector. So in this situation, that would be P. That's where it started. Then the terminal point, right, that's where it ended up basically. That is the ending point of the vector. So in this situation, that would be point Q. When we move things in a coordinate plane, you can really only move things up, down, left, and right, right? So when you're moving things around, you might have a horizontal component, so like a left-right movement, and a vertical component, or an up-down movement. So the horizontal component is the movement left or right. It's the movement left or right, which in this case was what? How did it move horizontally in this situation here with this little diagram? Yeah, well, it moved, how many units to the right did it move? 5, right? So that's my horizontal component for this situation. My horizontal component here would be 5 because it moved 5 units to the right. Trey, can you close your computer for me? Thank you. And then for the vertical component, it moved up 3 units, right? So that would be your movement up or down. And in this specific scenario, that would be 3 units because it moves 3 units up. Make sense so far? Kind of like slope, right? Very similar to that. Now, if you have a horizontal component and a vertical component. If you put those two things together, what that is called is component form. That's like telling you like a total movement. Like it moved this many units right or left, it moved this many units up and down, and that's your component form. So it combines the horizontal and vertical components. And it's written kind of like a coordinate point, except you don't use circular parentheses, you use like a little arrow, like pointy parentheses. So it gets written with this little like arrow type of parenthesis, like a little angle almost. 5, 3, and then you close it with another little angle thing on the other side. So now when you think about a coordinate point, isn't a coordinate point X and then Y? So wouldn't it make sense for your component form to also be then kind of like X and then Y? So it's your horizontal movement and then your vertical movement. Positive numbers means it's either going up or right. Negative numbers means it's either going down or left. So this component form would literally mean whatever point you have, doesn't matter what your point is, move it 5 units to the right and 3 units up, okay? If it had a -1 and a -3, that would mean move it 1 unit to the left and down 3 units. Does that kind of make sense, guys? Okay, all right. So now we use these things, our components and horizontal movements, vertical movements. We use them in transformations. A transformation, what that is, it is a function that moves or changes a figure in some way to make a new figure. So actually, all of our things that we talk about this chapter are going to be transformations. Rotations, that's a transformation. A reflection is a transformation. A dilation is a transformation. It's taking a shape, moving it around, making a new shape. When we have a transformation, you're going to have an original figure, right? What you started with, and then a new figure. They don't call them original and new, though. The original figure, they call the pre-image, right? Pre, like before. So that's the pre-image, and therefore the new figure is then just the image. So the pre-image and the image. If you look at this picture here, this is a transformation. It's actually specifically a translation. It moved. You had this triangle ABC, and it moved to the right, right? Now, if you take a look at your picture, do you guys see a little difference in our labeling for these two pictures? Anyone notice a little difference in the labeling? Yeah, it's a little dash. We call that like prime. So if this is A, then this is A prime. If this is B, then this is B prime. If this is C, then this is C prime. If there's 2 little dashes, it would be double prime. If there were 3 little dashes, it'd be triple prime. That indicates to you, hey, you took this point and you moved it. It's 1 little dash because you just moved it 1 time. You moved it to the right. And that's how, if you're graphing this, I'm gonna, can you sit up, please? That's how I'm gonna be able to tell which one's your starting picture, right? Your pre-image and your image. If you don't have labels like this, is it easy to tell which one's which? No, not really. Okay, so your pre-image here, your pre-image is this picture, your triangle ABC. This is your pre-image. So triangle ABC is your pre-image. You took it, you moved it, and your new picture is this triangle here. A prime, B prime, C prime. And how you would write that is literally you'd put your triangle symbol and then A prime, B prime, and C prime. And that's how you can tell the difference between them. Okay. Now what this is, since it just moved to the right, it didn't like flip around or rotate, it didn't change size, anything. This is called a translation, which can sometimes easily be confused for transformation. Transformation is like our general word for all of them. Translation is specifically up, down, left, right. So a translation moves every point of a figure the same distance in the same direction. So the same distance in the same direction. Sometimes you'll do a translation with a vector, like what we talked about up here, like 5, 3. Move it right 5, move it up 3. But sometimes they're written slightly differently. Sometimes they're written as something called a rule. And a rule is more written like a coordinate point almost. So for example, if you move the point, I'm just going to pick one on my picture here, like A. So if I move the point -4, 4, I just picked A, using the vector 6, 0. 6, 0 means right 6 and then not up or down at all, right? Because the vertical component 0. How you would write this as a rule is you would do x comma y. That says you're taking a point, any generic point, x comma y, and then an arrow. The arrow is literally like you're moving it, right? And then what you do, if I'm taking a point and I'm moving it right 6, aren't I technically just adding 6? So what you do is it's literally just becomes x plus 6, comma, y. And then did I move my y part at all? Like, did it go up or down at all? No, so y actually stays the same. So this is just like an alternative way to write it. Okay, so these two things here mean the same thing. This is a vector. That's a vector 6, 0. That means move it right 6, not up or down at all. This is a rule. Take any point x, y, add 6 to your x, which means move it right 6, do nothing to your y. That means don't move it up or down at all. Same idea, just written in 2 different formats, okay? And there are both on your homework, so and we practiced both. So just this one, it almost just tells you, it's nice to use if you don't have a picture. You literally treat it with like addition and subtraction, okay? If you're moving something down, subtract it. If you're moving something up, add it. Okay, so let's try this out. Example 1 says segment XY given by the endpoints x -2, 3, y is 1, 2. Before you even look at what your problem's asking you to do, I would sketch it. I'm going to give you a little heads up here. It is not super easy to draw a nice straight segment on this tablet, so bear with me. Okay, that's why you guys have rulers. Rulers don't really work on this. So I'm going to start just by drawing my original segment. So my original segment is x is -2, 3. So from your origin, that's left 2, up 3. And I'm going to put a little x there. And then y is 1, 2. So that's right 1, up 2. I'm going to put my y there and then connect it. Make sure you put your x and your y. If you don't put an x and a y, will I know which one's your first segment versus your second segment? No. Okay, so now I have my first segment and it says use the vector use the vector 1, -4 to translate x, y. So if this is your vector, this is telling you how to move it up, down, left, right. Does anyone think they know what the vector 1, -4 means as far as where to move it. Any ideas? Kaden? Opposite. This is horizontal and then this is vertical. So if it's horizontal 1, that would be right 1, and then vertical -4 means down 4. Does that kind of make sense? Because it's horizontal and then vertical. Because like think like a coordinate point. Isn't a coordinate point X and then Y? So you move in the X direction first and then the Y direction. Okay, so this is your horizontal movement. This is your vertical movement. Yeah, so everything's going to go right 1, down 4. And then you can almost just count it out like a slope. Does that make sense a little bit more, Kaden? Yeah, okay. So I would move it just like you would move with like slope, like rise over run. I would start at X and I would count right 1 and then down 1, 2, 3, 4. And then mark that as X prime. Put your little dash. And then from your Y, do the same thing. Count right 1, down 1, 2, 3, 4. And then that's Y prime. And then connect it with your little segment. Your segment should be the same exact size, right? It's facing the same way. It just moved right and down. Okay. Now it says state the points of X prime and Y prime. Now, we're going to go based off our picture, but then I'm going to show you how you could have done this without a picture in general. If you take a look at X prime, what coordinate point did X prime become? -1, -1. What coordinate point did Y prime become? 2, -2. Okay. Now, well, that's easy to see with our picture, right? But what if we didn't have a picture? Well, if you take a look, didn't X start off at -2, 3? And then you applied this vector to it, 1, -4. Well, I have a question for you. What's -2 plus 1? -1. Isn't that where your X coordinate ended up there? Okay, then your Y was 3. What's 3 minus 4? -1. Isn't that what your coordinate point ended up at? Yeah, so it's just like you're taking these, you added 1 to your X, and you subtracted 4 from your Y. Right? If you looked at the same thing with your with point Y, 1 plus 1 is 2. 2 minus 4 is -2. So that's just another way to think about it if you don't have a graph. And that's kind of where this rule comes into play. See here it says state the rule. The rule kind of helps you think about it in that way. So if you look at rules, that's what I highlighted up here in yellow. So if we write this as a rule, we would do X, comma, Y, and then an arrow. That means any generic point, X, Y, becomes, that's what the little arrow is supposed to signify. And then you'll put X, and then your vertical component was 1. So it would be X plus 1. I'm sorry, your horizontal component, I said that opposite, I think. Your horizontal component was 1. So you add 1 to your X. Your vertical component was -4. So what do you think you would do to the Y? Subtract 4 minus 4. Same thing, just written in a slightly different way. Because it would mean the same thing. You would just add 1 to all your X's, subtract 4 from all your Y's. Do I have you guys so far? About the rule? Okay, so with the rule, L, what we did is, wasn't your horizontal component 1? So technically what you do is you write a coordinate point, any generic coordinate point like X, Y, and if your horizontal component is 1, you just add 1. And then your vertical component was -4, so we just subtracted 4. Better? Okay. Now, sometimes the rule form throws people off a little bit. I think it's just because there's a little extra information going on. It looks a little bit more complicated, but it means the same thing. People at home, any questions yet? No, okay. All right. So example 2, triangle ABC has points where A is 0, 3, B is 2, 4, and C is 1, 0. What are the points of triangle A prime, B prime, C prime if the translation vector is -1, -2? And then we're going to state the rule. Now on this one, we don't have a picture, do we? We don't have a graph to work with. But that's okay, because if we have the component, or the vector -1, -2, what does this mean? What does the vector -1, -2 mean? If you had a graph, where is it going to go? Up, down, left, right, how many? Yeah, it's going to go left 1. Yep, it's going to go left 1 and then down 2. So what you can do is, isn't -1 where it's moving in the x direction? Isn't -2 where it's moving in the y direction? So you're going to subtract 1 from all your x's and subtract 2 from all your y's. Okay? So let's try this out. What I like to do, I'm going to give you guys like a process that I like to follow for this. It just, in my opinion, helps me stay organized. I like to go ahead and recopy all my original points down. So I'm going to write down A was 0, 3, B was 2, 4, and then C was 1, 0. Now the reason I like to rewrite that is that I'm not looking up at my directions all the time to figure out what my points were. Okay, and now I'm going to, sorry, that looks like an 11. Now I'm going to apply my vector to it. So my vector is -1, -2. So literally I am going to subtract 1 from x, subtract 2 from y. Do we understand why I'm subtracting 1 from x and 2 from y? Okay. So then when I do this, this is again just kind of like what I like to do. I like to then grab a different color. I put my little arrow just to be like, oh, okay, we're changing into this. So we're going to make this A prime, B prime, and C prime. Those are my new points. Okay, so A prime, ladies and gentlemen, what is 0 minus 1? -1, guys. Elle's not the only person in class. So 0 minus 1 is -1. What's 3 minus 2? 1. So that's my A prime. That's what I would get if I went left 1, down 2. All right, B prime. What's 2 minus 1? 1. What's 4 minus 2? 2. So B prime is 1, 2. And then C prime, what's 1 minus 1? 0. And then what's 0 minus 2? -2. Okay with that? We see how we can do it without a picture? Okay. And then the last part, it said to state the rule. So rule means write it like we did up here, right, with the x, y. So for our rule, remember you do x, y, and then your arrow, and then give yourself an open set of parentheses, and then put your x again. Now your horizontal component was -1. So I should put x and then what? -1. And then comma, put your y. Your vertical component was -2, so y -2. Good. We okay so far? Okay. Last one of these, and then what's our timing like? And then I think we'll take a little break and then we'll do reflections, okay? All right. So let's look at 3. It says graph triangle RST with vertices at R, which is 2, 2, S, 5, 2, and T is 3, 5. So let's graph that first. Be careful when you're graphing your original picture, guys, because it could kind of throw off the rest of your picture if you do something weird, okay? A big thing is when you're doing these, should your final shape really look any different than the one you started with? It's just going to be in a different place, right? If you have like a completely different picture, you did something wrong, go back and check your graphing. Okay, so R is 2, 2, S is 5, 2, and T is 3, 5. So this was R, S, and T. Okay. Now it says to graph its image. So this is my pre-image. Now I need to graph the image. After the translation, x, y goes to x plus 1, y plus 2. Can someone tell me what, I don't need to cross it out though. Can someone tell me what this means? What do I want to do to my graph? Where is it going to go? It is going to go up. How many? Okay, and then Andrew, what else is going to happen? Right one. Okay, good. So we are going to go right one and up two. And I'm literally just going to count it out. Could you use your coordinate points if you preferred? Yeah, so this is kind of like it's dealer's choice a little bit. If you like to do the adding and subtracting with your point, do that. If you're more visual and you want to physically count it out on your picture, do that. I would technically, if you had time, I would do both to check it. So we're going to go right one. So doesn't matter which point you start at. I'm going to start at R. I'm going to go right one up 2. So R prime is going to become 3, 4. So R prime is 3, 4, which should make sense with adding 2 or adding 1 and adding 2. Then S prime, you're going to go right 1 up 2. That should become 6, 4. And T prime, you're going to go right 1 up 2 again. And that's going to become 4, 7. Okay. And make sure you put your little primes on your picture. Okay. Questions, concerns? Caden, you awake? Making sense? Yeah? Okay. Abby, we good? Yeah? Okay. Okay, excellent. All right. We are moving on to reflections. Caden, sit up for me, please. All right. Reflections. Something you're going to see a lot with this is the term rigid transformation. What that means is that your shape isn't actually changing. Okay, your actual shape is staying the same. It's just moving to somewhere else in your coordinate graph. So just if you see that and don't know what it means, that's what that means. So a reflection is a rigid transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. And what happens is that a reflection in a line, any line M, maps every point P in the plane to point P prime. So same idea where you're going to start with a regular old point, and then when you move it, it becomes prime. So if you look at these two little diagrams here, this is just something to think about. If this line here, M, is your line of reflection, what this is saying is you would start off with point P, and it would reflect over that line to become point P prime. And you'll notice, aren't these little segments marked as congruent? That's because it has to be the same distance, right? That's what a reflection is. It'd be the same distance above, and then your new point would be the same distance below. Occasionally, you'll have a point that's actually on the line of reflection. It won't go anywhere then, okay? It's like it's sitting on that mirror. It can't go anywhere. This is where we have some rules we get to apply. honestly, a lot of reflections you can almost just count, right? If you're just flipping something over a vertical or a horizontal line, you can count it out. It's very easy to do. But what do you do if you have like a slanted line, right? Something with some kind of a slope. That's when it gets a little trickier. So we have a few rules here. We have 4 rules. That certainly does not cover everything, okay? But this is just 4 generic rules that we get to use. So if AB is any generic point, I don't use X and Y for these because if you take a look, we have equation like Y equals X, X axis, we end up using like those letters a lot. So I just call it AB, but it's just a coordinate like X, Y. If any coordinate AB is reflected in the X axis, that's your horizontal axis, then its image is the point, oh, sorry, highlighter. Then its image is the point A, negative B, or opposite of B. So A stays the same, your X coordinate stays the same, B, or your Y coordinate, becomes the opposite sign. If it was positive, make it negative. If it was negative, make it positive. If AB is reflected in the Y-axis, that's your vertical axis, then your image is the point opposite of A, comma, B. So this time A, or your X value, becomes the opposite. If it was negative, make it positive. If it was positive, make it negative. And your B, or your Y value, stays the same. If AB is reflected in the line Y equals X. Now, this equation sometimes throws people off. So let me show you what that means. I'm going to kind of sketch it off to the side here. I'd like you to do the same. So if you have a little coordinate grid, think like Y equals mx plus b, where m is your slope, right? And that's whatever's in front of x. Well, if you look at this equation, isn't there technically a 1 in front of x? So that means a slope of 1, and I don't see a b value, do you? So that means it's actually 0. So this is a line that goes through 0, 0, and has a slope of 1. It would look something like this. That's the line Y equals X. Okay, it would look something like that. It's a slanted line with a positive slope going through 0. So if you had a point, right, like a point over here, and you're going to reflect it over, right, it's going to end up over here somewhere. Okay, again, this is just like a general sketch, but that's what we're doing if we're reflecting it over that. The rule, these are the ones that are tricky. These ones are harder to count out. So this is where your rule becomes important. The rule for this is B, comma A. So you take your original point, A, comma B, and you flip it around and make it B, comma A. So if it was 1, 2, make it 2, 1. Then this line is the same idea except a negative slope. So I'm going to sketch this one out as well. So if you have an XY axis here, this line would look like this. It goes through 0, 0, and have a negative slope. So that's Y equals negative X. All right. So this, again, similar idea. If you had a point over here, you'd flip it over, it'd become over here. Again, this one's a little bit harder to do visually. So our rule for this one is AB is going to become negative B, negative A. Or opposite of B, opposite of A. So take your sign and switch it. So if it was 1, 2, it's going to become negative 2, negative 1. Not all reflections are going to have rules. Because are these the only 4 lines that ever exist? No. They're the ones we probably work with the most, okay? But you can technically reflect something over any vertical line, over any horizontal line, you just count it out. So if you don't have a rule, just count it out. So to reflect a figure over any horizontal or vertical line, remember a point of a reflected image is the same distance from the line of reflection as the corresponding point, which sounds complicated, but all this is saying is if your original point was 5 units above, guess where your new point should go? 5 units below, okay? You awake over there? You sure? You don't look awake. I'm not getting awake vibes. I'm getting very tired, sleepy vibes. Okay, so example 4. So this says graph triangle ABC with vertices A is 1, 2, B is 5, 2, and C is 2, 1. So let's graph that first. Don't forget to label it. So A is 1, 3. B is 5, 2. And C, oh wait, what did I just do wrong? Oh, nothing. Okay, I had labeled my other one wrong. And C is 2, 1. So that goes here. Okay, so there's my triangle. Now it says to reflect triangle ABC in the line y equals 2. Well, is y equal to a rule up here? Is y equal to the x-axis? Is y equal to the y-axis? Is y equals to the same line as y equals x? No, it's not any of these. Because does everything have a rule? No, so we're going to start off with one that just straight up doesn't have a rule. Okay, so now where is the line y equals 2? It's a line. Anyone know where it needs to go? This is pulling on our Algebra 1 memories right now. The line y equals 2, do you think it should be a horizontal line or a vertical line? It's horizontal because it needs to go through 2 on the y-axis. So 2 on the y-axis is right here. It's actually a horizontal line right here. That's what we're going to flip it over. And you might be like, how in the world am I supposed to flip it over? Isn't it laying on top of it? Well, that's okay. We're just going to count it out. Okay, we're just going to count it out. So you are literally, if you have something like this, I would maybe make yourself a note. We are going to count the units. That's what we're going to do. Let me grab a color we can easily see. Okay. Now I'm going to just go in alphabetical order here. If you take a look at A, isn't A 1 unit above? So where should A prime go? 1 below. Does that kind of make sense? So if you're 1 above, if you're reflecting it, you need to go 1 below. So we're going to go 1 below our line of reflection. Okay. Well, now look at B. Where's B? B's on the line. Can it go anywhere? No, it's on it. It's going to stay there. I'm just going to draw over it and put a B prime there as well. Okay, look at C. C is 1 unit below. So if it's 1 unit below, how would you flip it over it? Go 1 unit above. That's C prime. And then just connect your 3 dots. And isn't that what the picture would look like if you just flipped it over? Yeah. All right. Those ones are the trickiest ones. I don't know, they just throw people off because you want to look at a rule, okay? But not everything is going to have a rule. Questions about that one? All right, let's look at 5. Reflect triangle ABC, given that A is 3, -1, 1, so I'm just going to go through and draw this. A is 3, -1. B is 3, 2. And C is 1, 2. So you have like a little right triangle going on here. Oh no, what did I just do? I did something weird. Hold on. How did that happen? Strange. Okay. Don't know. There it is. So this time it's telling us to reflect in the line y equals -x. I'm tired of talking to myself, so Colin K, what rule do we use if it's y equals -x? Oh, okay. Yeah, right here. Yep, we're going to use this rule right here for the line y equals -x, which means -a, -b. I always like to rewrite it next to it. So like if I see y equals -x, I know I need to use the rule -a, -b, or opposite of a, opposite of b. So I'm going to actually kind of do the same thing that I did on the front page, where I'm going to recopy it down and then write what my new points should be. This is not, I don't like to simply do these visually. I like to do both personally, but do what works best for you. So A was 3, -1, B was 3, 2, and C was 1, 2. And I'm going to take these and apply this rule. So A prime, I need to take my 2 points, I need to flip them around and make them the opposite sign. So that means this is going to become +1, -3. Does that make sense? Okay. So if B is 3, 2, Kaden, what would B need to become? Well, you do switch the signs and then you also have to flip them around. Yeah, -2, -3. And then if C is 1, 2, Abby, what do you think C prime would become? Right, -2, -1. And then we can just plot these. So A prime is 1, -3. B prime is -2, -3. And then C prime is -2, -1. And if you take a look, think about what I told you this line would look like. If you had like a little dotted line running through here, doesn't that look like a mirror image over it? Yeah. Always a good little way to test it out. See if it makes sense with the picture. All right, I want you guys to try out example 6, and I'm going to call on people for my points. So example 6 is almost the exact same thing, same starting picture, just you're applying a different rule. So this rule is the x-axis rule. So if you look up above, the x-axis rule is A opposite of B. So you keep the points the same, just make the B coordinate the opposite sign. So while you guys work on it, I'm going to start drawing the original, but then I am going to call on people for my new points.
No, I was just confused because these were all the same numbers. I was just.
Oh, like this part? I just like to recopy them down. You're not required to do that. I just think it helps that when you're like switching them around. All right, so for this one, we are reflecting this over the x-axis. What's kind of nice about ones like this is you really like need the rule if you don't want to use it. Can you just like count it out? Yeah, if you want, or use the rule, whichever. So let's get our new points. We need A prime, B prime, and C prime. Ethan, if A was 3, -1, what do you think A prime would be? Yeah, it would be 3, +1. Good. 3, +1. So here is A prime. Danny, if B was 3, 2, what do you think B prime should be? Okay. No, Gannon, what do you think B prime should be? It's really hard to hear you. Oh, okay. Don't worry about it, Gannon. Let's see. Olivia. Well, we're bound to get it eventually. Olivia, what should B prime be? You don't know? Okay, so B prime, we're applying this rule, which is A opposite of B, okay? So right now your point is 3, 2, right? So if you applied this rule, your first point is going to stay the same, your second point is going to become the opposite. So how do you think you would apply that to the numbers 3 and 2? Anybody at home? I'm not sure if we're awake or paying attention. Yep, thank you. It would be 3, -2, right? Because A stays the same, B changes. Okay, so then for C prime, somebody at home, let me know that we have a pulse. What would happen with 1, 2? 1, -2, good. Gannon, I see that you responded in the chat as well, thank you. Okay, nicely. I know you're awake, okay. All right, so B would be 3, 2. I'm sorry, 3, -2, so that goes here, and then C prime is 1, -2. So that's here. All right. Are there questions? I feel like my in-person people are good. My at-home people, though, do we have questions? I can't see you, so I can't see if your face looks confused. So you have to let me know. Are we understanding now where these came from? Olivia, do you see what I did with B prime? Okay. All right, last thing. Last thing is called a glide reflection. These are going to happen a lot. And what these are, it's like you're doing two different things. A glide, think like you're going to move it, and then you're going to flip it. Okay, so a glide reflection is a transformation involving a translation. So up, down, left, right, followed by a reflection. Now, I do want to tell you guys, anytime you have to do more than one thing, you always use your most recent set of points. So I'm going to take a picture and I'm going to translate it, and then I'm going to take that new picture and reflect it, okay? So anytime you need to do a series of things, use your most recent shape. Because if you always go back to your original shape, did you actually translate it and then reflect it? You're trying to like move it in multiple ways, okay? So example 7 says graph triangle ABC with vertices at A, which is 3, 2. B is 6, 3. And C is 7, 1. Okay, so there's my triangle. I need to now do this glide reflection. It tells me to translate it using the rule x, y goes to x plus 2, y minus 6, and then we're going to take it and then we're going to reflect it over the y-axis. So what I'm going to do is I'm going to rewrite my new points so we can kind of see the progression here, or rewrite my original points. So A was 3, 2, B was 6, 3, and C was 7, 1. All I just did right now is I just recopied my points. That is completely optional. I just like to see it so you guys can see what I'm doing. Okay. Now, if we're going to translate it using this rule, x plus 2, y minus 7, y minus 6. Can someone explain to me what this means? Where's my picture going? Up, down, left, right, how many units? It's going to go right 2 and then down 6. Okay, so this means right 2 and then down 6. Now, could you do that on the picture? Yes. Could you do that with your points? Yes. I don't care which way you like to do it first. My guess is most of you are going to prefer counting. Okay? So I'm going to go from A, I'm going to go right 2, so that's 1, 2, and then down 6. 1, 2, 3, 4, 5, 6. And my A prime, make sure you label it, should end up at 5, negative 4. Then from B, I'm going to go right 2, down 1, 2, 3, 4, 5, 6. B prime should end up at 8, negative 3. Do I have you guys so far with that part? The right and then down? Yes, no, maybe? Okay. And then C prime, right 2, I know it kind of gets a little cut off. You can estimate a little bit, that's okay. So right 2 and then down 1, 2, 3, 4, 5, 6. So there's C prime. And that should be at about 9, negative 5. Now, the reason I opted to also write these down is because it makes it a little easier to apply your next rule then, but it's up to you. You can also just do it visually. Because the next thing I'm being told to do is to reflect it across the y-axis, which is your vertical axis, right? So you're literally going to take your picture and you're going to flip it over. So if you want to do it visually, see how A prime is 1, 2, 3, 4, 5 units to the right? You would draw your next one 5 to the left. Now, don't I? Yeah, that's the next way I'm going to show you. Now for this one, something with the labeling, guys, I moved it once so I have it as prime. You're going to move it again, so you're going to put double prime. You're going to put 2 little dashes, okay? So now I'm trying to figure out what A double prime is going to be. My rule, if you go up for the y-axis, is opposite of A, comma B. Now, do you think I should take my original point or my new points? My new points, right? You're moving it and then reflecting it. So take your new point. You're going to make the A term opposite, B term stays the same. So that's negative 5, -4, which is the same thing you would get if you just flipped it over. So there's a double prime. Okay. What would B double prime need to be if I applied that rule? Andrew? -8, -3, good. So -8, -3. And then what would C double prime need to be? Andrew? -9, -5, good. That would be down here about. Good. And that happens a lot. You'll have to do like